Okay, let's take a look at this problem where we have a bucket of water is pushed from left to right with increasing speed across a horizontal surface. All right, so we have this bucket on a horizontal surface. Here's our surface, nice and horizontal there. And there's our lovely bucket, and it's accelerating in this direction. And it's important that it's accelerating. If it was moving at a constant speed, then there would be no net force, and the pressure would be the same everywhere. But it is accelerating. And we're looking at 2 points at the same level. So the height is the same, so we don't have to worry about the pressure from the fluid above it, the little rho GH there. That's going to be the same for both of them, so that doesn't matter. We just have to look at what's happening because of this acceleration to the right. So let's take a little volume element of this water, or fluid, whatever it is. And I'm going to say that I'm making the height small. Well, let's just say it's very small because we're not worried about the height difference. So let's just make it little cubes. Very small, so we're not worried about the difference in the having a different pressure on the top than on the bottom. So we have little volumes of dx cubed is the volume. And so the mass will equal the density times the volume. So the mass will be the density times dx cubed for both of them. So they'll have the same mass. So mass 1 equals mass 2. And if we look at the acceleration, we know that it's accelerating to the right, and so we have to have a net force to the right. So the pressure on this side has to be greater, the force on this side has to be greater than the force on that side. So the net force equals the force on the left minus the force on the right. And that has to equal the mass times the acceleration. So they have the same acceleration. So the force on the left minus the force on the right for the block to the left has to equal the force to the left minus the force to the right from the block on the right. So those two things have to be the same. Now these are not the same forces, so this is force on the block on the left and the force on the block on the right. So I've got my two little volumes, and I've got a force here and a force here, and I've got a force here and a force here, and the difference between those two forces have to be the same, but the forces themselves don't have to be the same. So we know that this force is greater than this force, and that this force is greater than this force. So that means across our entire bucket, the force on the left is greater than the force on the right, or the force is, this is greater, force on the left is greater than the force on the right. So the force is decreasing as we go across the bucket. And so when we're on the the block on the left, both of these forces are greater than both of these forces. And so we have a greater force on the left. And we know that pressure equals force over area. And we made these squares, and so the pressure equals a force over dx squared. And since the force on the left is greater, then the pressure on the left is greater. So in this problem, the correct answer is B.